Hey, hello everyone. So welcome to another webinar session in GDG Cloud Singapore. So yeah, it's been a while since our last webinar session. I think the last session was, let me quickly check. I think it was sometime in August. So that's a whole August, September, October. I guess a whole 2 months since our last webinar session. So yeah, with that, okay, so rather than me like rambling on and on, like, with all this whole COVID situation and everything, like, we all should be staying at home and keeping safe. I mean, seeing the COVID numbers are pretty high in Singapore, especially. Yeah, rather than me rambling on about that, let's quickly jump into our speaker for today, which is Derrick Wong. I think he spoke in the previous webinar session as well. So the previous webinar session was code maintainability. Yeah, so a bit hard to pronounce that word. So his previous session was that. So if you wanted to get some tips about that, you can catch that previous session. But today's session is about secure software supply chain. So let's quickly get Derrick on board and let's add him to the stream. Hello, Derrick.
Hello, Harry.
Yeah, let me switch over to your slides. All right, your slides are up. The floor is yours.
Okay, thanks, Harry. Hello, everyone. Really glad to be invited to this webinar again. As Harry mentioned, I think this is my second webinar for GDG community in Singapore. Really glad, really excited. Unfortunately, we cannot meet physically, personally. Hopefully, the travel will be opened maybe next year sometime, right? So that I can come to Singapore, right, to share in front of you guys. So, as mentioned, today's session is about securing software supply chain, and there there are two very important elements in this topic. The one is software supply chain, as lots of you may already know or using. Usually we call it CICD, continuous integration and continuous delivery. But we have another term, just software supply chain. Basically, they're the same. The reason of having a software supply chain, I guess, is because lots of people, lots of company, they want to go fast. They want to deliver their software faster because software is eating the world. And the other important element, which will be my focus today, which is security. Obviously, lots of companies, especially for enterprise, like a bank or government, right? They want to go fast, but at the same time, they want to go secure. And sometimes security is more important than the delivering speed, right? As you can imagine, a bank can only release software if they believe that software is safe. For example, it will not leak any personal data, right? It is good in quality, and then they release it, right? It's not difficult to understand. So today, I'm going to cover. There are actually quite a lot to cover, and we'll talk about the different stages. If we have time, I think we'll have enough time, and we'll do a demonstration. I will not demo everything, but I'll talk about the concepts and then demo some of the unique concept in this securing software supply chain solution. Okay, so yeah, let's start. Before I go into the details, I thought it may be useful, maybe good to show you some of the numbers, right, to set the stage. The first, it only take 41 minutes, right, for an open port, for application with an open port with weak security, to be hacked in 41 minutes. Just want to show you. I mean, before I saw this, I thought, yeah, maybe it may be okay if I, create a web server, have a public IP, but I just do not advertise it. I don't tell anyone it will be okay, but actually it is not. It will be hacked. Obviously, there's some scanners over the internet that just scan the IP and then scan the port and then see if there's any weak security, any vulnerability, any weakness, right? Basically, and then try to hack in. And then in 2020, 43%, in terms of the vulnerability, 43%, the vulnerability is actually from the outdated package. That's the majority part. And about 1/3 is based on the weak password. Yeah, I think I saw something previously, according to a survey. Actually, quite a lot of password is just based on very, very weak password, like the actual word password, or 1 2 3 4 5 6 7 8, something like that. Yeah, it's hard to imagine, right? So these are some of the most of the vulnerability coming from outdated package and weak passwords. And then 60% of the enterprises experiencing security related issue with container in 2019, about 2 years ago. So it's not hard to imagine, right? Because this kind of container technology is rather new, and lots of enterprise they're adopting. They're in the journey of adopting these kind of container or cloud technologies. So quite a large number, they are actually suffering, or they having security related issues with those container image and the container platform and the applications. 47% knew that they had vulnerability in production. Is quite high. I think this imply they knew there's vulnerability, but they cannot patch it quickly, right? 47% they knew it, and then another 46% they don't even know it. They don't even know that there is vulnerability. Maybe they haven't really got any scanning tools, checking tools, right, to help them to find out the vulnerability. That's very, very high in terms of the percentage. Now just take 15 minutes for a private key. If you push it to GitHub, right, just take 15 minutes, right, for crypto mining to start. Obviously, again, there are scanners out there, and they'll just keep checking all the repository in GitHub. If you accidentally check in your secret private key, then someone will try to use it to create lots of virtual machines, right, and then start mining. Right. All the numbers I'm trying to tell is that security is obviously very important. You want to go fast, but obviously you need to go secure. I've been told by some of the colleagues in another country. They said, "Oh, my customer just want to go fast," right? They are kind of a startup. They don't really care about security. I cannot agree with that, because if you can go fast, but if you do not care about security, you eventually suffered. If you leak any your client's data, right, it will be fined. In some country, it will be fined heavily, very heavily. And then about sure you heard about those ransomware. You may be asked, right, to pay to hacker in order to get back your own data or your client's data. So you want to go fast, but security is also important no matter what industry you're in, no matter whether you're working in an enterprise or a startup company. I think they are security important for all the commercial company. Now, I'm sure if you're a developer here, I think most of you will use some level of open source software or open source framework or development tools. The point here I want to make is, can you really trust everyone, even if you are the only one, create a project, create application, and then you use some open source library, for example, Spring Boot, for example, React or Node.js, Core.js. These open source library, they're open source, and then they contribute by lots of developer, and a lot of them you don't know, right? It's not in your company. So can you really trust everyone? I think the answer is obviously no, right? Even the projects created by you, if you use any of these open source library framework, then you're subject to certain kind of vulnerability or weakness. So do not trust anyone, right? So today we're going to talk about some kind of best practices. I'm not really, well, as mentioned earlier, right, there are two major important components, right, in securing software supply chain. The first one is security. The second one is the CICD or supply chain. I'm not going to focus in CICD today. So, I mean, all these are very important, like repeatable process, automate everything, version control, build-in quality, etc. Not going to focus on all of these today, but I'll focus in the last one, which is the accumulate trust. Right? How do we collect the trust? What's the difference between implicit trust and explicit trust, right? So yeah, that will be my focus, and obviously I'll also cover some of the security checking in different stages. So right, first one, the trust in software supply chain. This is a oversimplified version of CI/CD pipeline. From the left, you have your source code, right? As a developer, you commit your source code, and then the SCM or GitHub, GitLab, right? The repository will trigger the pipeline executed automatically or periodically. And then those pipeline, the CI pipeline will build and test your source code, and then create artifact, store it in the artifact repository, and then deploy using a continuous deployment tool to staging environment, and then to production environment. And then you have your monitoring tools to keep track of the status of your applications and the system, right? The trust, there are trust in this software supply chain. The first one, like when you commit the source code, right? You trust that because it works in your box, it works in your local laptop, and therefore you commit it, right? And then trigger the CI/CD pipeline. And then after the build and test, the CI pipeline, right? After all the tests pass, right? You trust that it, the quality is good. And then you trust your artifact registry. You trust your process to deploy your application to a cloud environment, etc. All these trusts say they are implicit trust. What that mean is implicit trust, some form of how do I put it? It is not really verifiable. Yeah, you can tell. You can do it by just sending email. Say, hey boss, I've done my part. I commit my source code into the Git repo. I've run all the tests already. So please deploy it to the staging environment, right? I mean, this is implicit trust, and it is not auditable. It is not verifiable. And so I think the point here we're trying to make is by adopting, instead of implicit, you should adopt explicit trust. And then I'll explain a little bit more in the slides later. So you should start apply explicit trust, right? Don't trust a colleague sending you an email saying he done the security checking, right? Don't rely on that, right? You need to rely on something else, right? Some more, some evidence. When, where, how did that, security scanning been done? So collecting trust. This is one of the very important concepts in this solution. That means if a event or action be triggered, and then the action is completed without any error, then you should be able to create a note on the artifact and then sign it, cryptographically sign it. This is the trust, explicit trust we're trying to explain. So, for example, you have your code scanning tools, right? The CICD pipeline trigger a code scanning tools, right, to make sure there's no vulnerability, to make sure there's no weakness in your code. This is the action I mentioned, that event or the action triggered. And if that scanning tool is completed without any error, should be able to create that node or metadata and store that metadata in some kind of metadata store. And then that node need to be cryptographically signed with a private key so that it is non-deniable, right? And then this is what we call explicit trust. So by converting from implicit to explicit, you now do not need to trust an email from from a colleague. You now trust the crypto signature, because, as you know, also, of course, we assume that you have proper key management system, right? And then only that tool got the private key, or only that person got the private key. And then this will be signed using the private key, and then you use the private key to verify the signature in the later stage. All right. So so this is the collecting trust concept. We'll use it later I think in the 5th stage. I'll go through these with you guys. So that collecting trust, this is just one example. And throughout the software development life cycle, you need to collect a lot of trust, right? Not just one, because you have a lot of tasks to be executed in this CI/CD pipeline. This is also a oversimplified version, right? From the left, after you commit your source code, your CI/CD pipeline properly will trigger a lot of scanning, right? And this is one of the important area also. When I met a lot of enterprise client, they implemented the CICD, or continuous integration, continuous delivery. They still rely on some before they push their artifact to the production, there will be a very heavy security scanning stage, right? That performed by their security team, right, to make sure their artifact is secure and then align with their defined standard. My point is, lots of customer, lots of enterprise are doing that at the later stage, right, to make sure the security, to make sure their software is secure. But instead of doing that, what we're trying to tell our clients is that instead of run all these security check at the later stage, you should do it early, or we call it shift left on security, right? Or someone call it DevSecOps. Basically, they're the same idea. In order to allow your the deployment fail fast, right? If that for example, if the binary gonna break some of the security rule, right, break it quickly, and don't break it after running all the binary all the unit testing, integration testing, deployed it, right, and to the UAT environment after all these exploration testing, which take days. And then you say, okay, sorry, your software is not secure. We do not want to do that. We want to do it quickly, right? We want to do it fast. So instead of running all these scanning on the right, we recommend to run it on the left. So you can see this a pipeline, all these linting, secret scanner, SAST, etc. They start very early. Of course, you need to run those unit test, integration tests also, right? And then after the first, the left column, you build the image, publish the image to an artifact registry, and then you have another test like container structural test, image scanner to make sure there's no CVE or no severity one CVE, and then you accept the security, etc. And then you deploy to development environment, run some more tests, and then deploy to QA and production eventually. So the point here is that you should collect trust throughout the the pipeline. For example, after the security acceptance, you should create attestation, right? It is a form of explicit trust, which is basically is the proof or the evidence or cryptographic evidence saying the test is done, right? So, and the test run successfully. And then this attestation will be stored in the metadata store as mentioned. So create attestation, and then another part is that you need to use this attestation, right? You need to create a policy, right? In your runtime environment. For example, your development environment, your QA environment, production environment, you should have a set of policy saying what kind of attestation is needed in order to run in a, for example, production environment or in a QA environment, right? So you should have some kind of mechanism in your runtime to allow or reject the workload being run in the runtime environment. I'll tell you a bit more later. Okay. Next, I'll talk about the 5 build stages, from secured baseline, source code, artifact before deploy, deployed artifact, and how to promote your artifact, across environments. First, the secure baseline. I think the concept is simple, right? You need all these baseline in order to secure. If you do not do this, if you skip this, if you neglect the baseline, just like you saying you want to secure your home by closing all the windows and forgot there is a back door, right? Simple. So all these are very important. We are not going to drill into details of all these, like the physical hardware, infrastructure, network, firewall, right? Or hardened VM, hardened container image, etc. But I'm telling you, all these are very important. You need to have all these baseline, right? If you're not fulfilling these baseline requirement, there's no point. Right? Even how secure your CICD pipeline is, there's really no point. We'll focus more in source code and then the artifact before and after deploy and the promotion. All right. First one, secure the source code topic. I'll talk a bit about the software languages. It actually matters, and then a bit about source code change management, and then how to secure the source repository, how to identify the malicious code early, and avoid exposing sensitive code, and then testing. First, this is some figures trying to tell you the language, the choice of selecting a programming language actually matter. Some languages are memory safe, some are not. For example, C or C++, they are not memory safe language. And Java, Node.js, C#, they are memory safe language. That means in the non-memory safe language, you subject to data leak. For example, what we call out of bound error. In some case, if you use some non-memory safe language, the program may be able to read something not suspected, right? For example, in an array, you maybe end up reading something not belongs to that array, and it could be some sensitive information. So this is the behavior of non-memory safe language like C, C++, but in the Java world, Node.js, they're memory safe. So use those memory safe language is the first recommendation, right? Java, C#, Golang, etc. The second one, the source code management. Our recommendation is to use create an organization-wide code review practice to implement source code management process, and that restrict primary branch access solely to the CI2 service account. In order to create new features, right, developer creates short-lived branch that not only isolate the feature code, right, but also require creating a pull request or merge request, right? Creating the branch indicate that the feature code is ready to be reviewed, accepted, and merged into main code branch. This is our recommendation, right? Use these. Some people call it trunk-based development. Basically, yeah, there's a main branch, but all the development, the active development, will be remain in the feature branch. And then once they done create pull request, someone can review the pull request and then decide whether this is good in quality, good in security, and then merge into the main branch. Use code owner, right? Code owner in GitLab or GitHub, they support code owner also. It's a text-based file that integrate the owners and the principal for either an entire repository or just a portion of the repository. The file let the platform automatically include named individual in code review, right? Only those owners can do that code review, and that's also mean only those code owners can merge your the new features in the feature branch into the main branch, right? This is also our recommendation to use this mechanism to protect the main branch. And then usually those code owner or more senior developer in the team, right? They have a more holistic view on the overall system, right? They will be the code reviewer as well. Identify malicious code early. As mentioned just now, instead of doing it in the later stage, we should do it in early stage. If there's anything wrong, right, fail quickly, and this will create a fast feedback loop to the developer so that they can fix it very quickly, right? Do not need to waste a lot of time on those, performance tests. Lots of testing need to be done in the middle, so do it early instead of later. To identify the malicious code, there are few check we suggest. The first one, the linting and syntax, right, to make sure your code align to your organization defined standard. And then the source code and analysis tool, right, to scan the source code, and then some common witness enumerations to check whether there's known CVE, etc. Right, all these tests should be run early to help identify the malicious code early. Avoid exposing sensitive code. This is not difficult to imagine, right? You do not want any sensitive information checked in to your source code management system, because as you know, once you check it in, there's no way, or it's very difficult to clear it, because it's basically it is a log system, right? It's collect all the changes. So you should have some secret scanner or pre-commit hook to make sure there's no sensitive information be checked in to the source code repository. You can use something like precommit.com, right? It is a hook that before you can commit the source code successfully, a tool will be triggered to scan your commit. For example, the source code you're committing, and then also the description you commit, right? So to make sure there's no sensitive information with the commit. And then something like license, to make sure you you're not using something that violate your organization defined standard. For example, some open source library, lots of you might know, if you use those kind of open source library, you also need to open source your application if your applications use that, right? So obviously a lot of enterprise, they might not want to open source their system, so they be important to have those kind of license scanner to make sure that those for example BSD free, right? If I'm not wrong, to make sure those library or software is not used in that organization. Logging also is important, right? Do not print log with sensitive information. At least you mask it before print it. And also that's not just about your applications, but also the building system in the, like the CI tool. Do not print the sensitive information like secret or password, right, to the output stream. But actually quite a lot of nowadays quite a lot of those CI system, they already mask those passwords automatically, so it should be fine. But also your application, just beware of the debug message or the output message. You should mask those logs. Okay, that's the first stage about the source code, right? Should use linting, secret scanner, SAST2, test coverage tools, license scanner, etc., to make sure your source code is good in quality and in security. And then this the third stage, artifact before deploy. So artifact before deploy, we'll talk about the building of the artifact, the structure of the artifact repository, vulnerability scanner, and then the dependency of the artifact of the applications. The building. I think there are two key points I want to raise out here. So I'm sure quite a lot of you familiar with Docker. If you're using, Docker desktop, if you're using Kubernetes, right? If you're using any kind of container orchestration system, you're familiar with Docker image. Want to talk about the building of this kind of container image. So usually you have your base image, right? As you can see in this on the right, this is a Docker file with base image, and then you run some command to build your own runtime, and you may also need to copy some of the source code or binary right to the image. And then the last one is the command to execute the application, right? Very basic. Want to introduce one concept called distroless base image. So distroless base image remove all the non-essential operating system dependencies, and it results in not only a thinner image, but also a image with reduced number of threat factor. In Google, we maintain a suite of distroless base image. So our clients in the organization can apply this principle approach to the custom immutable image pattern using our managed image for VM, for container. Advantage of using distruless image is to avoid, again, unnecessary binaries that an attacker might exploit. Meaning, if you use distruless container, distruless image, the attack surface area will be much smaller, right? Because it's make sure there's no unnecessary binary in your artifact. For example, if you don't need SSHD, right? You should not use SSHD. Normally, all these distruless container image does not come with this kind of like SSHD, etc. So yeah, you should leverage these image to make sure the attack surface area be very small. Artifact structure test. This is a test to make sure the Docker image or the artifact is lie with the defined artifact structure. For example, as you see on the right, you can define that, for example, the root folder should be in certain permission, and applications binary should exist, and should not have any bash shell, something like that, right? This is to make sure, again, the surface area, the attack surface area, small, right? To make sure no that someone, hacker for example, cannot access to the container runtime. If you do not have SSH access, right, it will be a lot safer. So yeah, this is the artifact structural test, right? So you can use to make sure your container image align to certain defined policy. Artifact repository. This can be a Docker Hub, or can be Artifactory, something like that, in the cloud or in your organization. So it provides centralized holding platform, for shared dependency libraries or third parties library. And now they usually often serve as a proxy for public repository that caching public library system with privately hosted repository. The artifact repository also provide centralized source of managing library for your organization, and allow organization to apply some kind of policy governance, privacy and filtering policy for binaries according to their compliance needs. And due to the central role in software development, consider these repository a potential risk when performing a threat assessment. Because of the risk, they should be private access only when possible, and to give special attention to any public visible repository or artifact. Make sure to isolate and segregate public artifact repository from your private one. Also, you should develop a deployment strategy for public artifact releases required by your business. Lots of the repository provide consistency mechanism like hashes to help ensure that artifacts have not been improperly altered. even within the repository that digitally signed image references should use the image digest as a cryptographic signature of the artifact and a proof of integrity. Right. So avoid snapshots, and that's mean, a lot of time, because it's more convenient, right? We use snapshot, like we tag the certain version of multiple version of the container or the artifact to 0.0.1 dash snapshot. It is convenient because we don't need to deploy the image again to Kubernetes. We can simply queue the port in Kubernetes, and Kubernetes will reload the latest image from the artifact repository. Depends on the policy defined in Kubernetes. Right? But this is not really a good practice. You should avoid snapshot because it is not deterministic. It's simple, right? How do you know the snapshots version is how can you make sure that the snapshot version behavior? You don't know. You may end up have double, have false negative or any unexpected behavior. So you should avoid the snapshot. Instead, you should use the digest as the in the deployment manifest. We also actually recommend to use a mechanism called hydrated instead of it's not convenient for to update the image tag the address every time, because the address will change every time, right? It's not convenient. So what we recommend is use a hydrated approach, whereby using some tools like scaffold to generate the address dynamically, automatically, so that you don't need to change it, update it manually every single time you change a bit of the code in your applications. Now, container analysis scanner and metadata storage. As mentioned a little bit earlier, to create attestation, you need some tools to sign it cryptographically using a private key, and then the signature will be sit together with the metadata and in the metadata store. And then at a later stage in your, for example, your Kubernetes runtime, you should have a kind of gatekeeper to allow or reject, right, based on the defined policy. So in Google, we implemented this using, and we open source it using Graphias, which is a metadata storage, and Critters, which is a signer and a server, right, to sign and verify the attestation. It is already implemented in Google Cloud, but if you want to use the open source version, you can feel free to use it. And then dependency scanner. As mentioned earlier, obviously, if you use open source library, there are quite a lot of developer contribute to the software, to the framework, right? So, and then also, let's say you use Spring Boot, let's say the MVC framework. And the MVC framework also depends on some transitive dependency. So there are multiple layers of dependency, right? You need dependency scanner to help you track and scan all the different level of dependency to make sure there are no vulnerability, or at least self one vulnerability in any of the dependency. Okay, so putting it all together, this is the this one, the you need container structural test, you need image scanner to find out the CVE, right? And then after that, you can create that security acceptance. Deployed artifact. First one, secret management. It's not difficult to understand, right? Obviously, you should not hard code the secrets within your source code, and you should not check in. Some people think that no hard code, I can put it in the properties file or XML file or JSON file, and then check in together with the source code, and that's obviously it's not a good approach, because all these property file, they are also source code, another form of source code. So what you should do instead is to use externalize those secrets, and then store it or inject it to the runtime using files or environment variable, right? Like for example, in Kubernetes, you can create secret, and then you can inject the secret to a pod through environment variable. Right? This is what you should do. Or you can also leverage some kind of secrets manager as an interface, right? So that the secret manager will do it for you. You don't need to care about that. You just need to use the key to extract the secret from the secret manager. Pen test and vulnerability test. So obviously this is scanner, application scanner for finding weakness from your applications. There are two type of tool, automated pen tool. One is a scanner, so the scanner will send the input to your application and then validate the results. There's another kind, proxy style. Basically, they will deploy a proxy just in front of your applications, and then you can run the test using tools like Selenium, right? And then obviously those requests will be intercepted by the proxy, and then the response will be collected. And then this proxy, because it's intercept all the requests and response, will be able to find out if there's anything not as expected. So these are two different styles of automated pen test, vulnerability test. The scanner is more suitable for known pattern, right? So for example, the scanner will send some some vendor, like some pen test vendor, they have a list of known pattern they try to validate, right? So scanner is good for that. Proxy will be for for unknown, right? It will be for unknown pattern, and then so it can be a part of the overall integration test as well, so that you do not need to create separate test specifically for the penetration test. You can use the embedded it as a part of the overall end-to-end integration test. Another one, isolating initial deployment. Or I think this one is for if you using tools like Kubernetes, Docker, right? It will be easier. If you use virtual machine, it will be more difficult. What that means is you have when you use this kind of continuous integration, continuous delivery, you may end up have a lot of different versions of your software, right, in the artifact registry, and then you need to test a lot of them. Instead of have a static test environment, our recommendation is that you have a dedicated test environment, and which is short living, meaning let's say this app A 1.4 is available in the artifact registry. You create a short living environment just for this specific version. You will create a database, load the test data into the database, deploy the version 1.4 into a Kubernetes cluster or into a namespace, depends on the approach you're using. And then you have a unique testing endpoint, and then run the test suite against this testing endpoint. And once the test been finished, just close down everything, close down the database, shut down the Kubernetes cluster, or just delete the namespace. This is the recommendation. Obviously, it will be in terms of the engineering point of view, it will be the challenge will be higher, because you need to be able to provision environment dynamically, create database, load data dynamically, right? And then you need to do a lot of scripts. You can use tools like Terraform to do that, right? It's very good tools, so that it will allow you to it will help you on lots of heavy lifting. Right. So yeah, but that's the basic concept of isolating testing deployment. Obviously, this test is more expensive comparing to the static testing environment, but there are quite a lot of advantage. For example, the test database. Have you ever heard about the test data being polluted? Contaminated, so that the test result is is maybe false positive. It's not expected. So by having a isolated deployment, especially on the database, where you can make sure only the data for that particular test case are loaded into the database, and then it will be much more easier for you to control the behavior. And then I also heard client told me that the testing database, they're so big, they're over 2 terabytes of data, so that their integration test very slow. That's also the reason why we recommend isolating initial deployment, because if you can and you should, have a very granular test case, those you only load those relevant data into the database for that particular test case or the test suite, right? Otherwise, your test will need a lot of time to run, and then again the behavior cannot be easily controlled, and it's hard to tell whether the test really successful or fail. So our recommendation again is to have isolated testing environment. Yeah. So after this is the artifact. After you build the artifact, you should be able to deploy it to development or testing environment, and then run some DAST dynamic scanning tools for that. And then the last stage is the artifact promotion. I'll show you. Yeah, I need to introduce another concept called binary authorization. So we talk about attestation, create the explicit trust. We talk about the gatekeeper, right, to verify whether this binary is got the attestation or not, right? This is exactly what binary authorization is. So it is basically a gatekeeper, right? It is an admission webhook in Kubernetes. When you're trying to deploy anything to Kubernetes, like a deployment or service or pod, right? This admission hook will be triggered, and then we'll try to verify whether the binary you're trying to push is aligned with the policy or not. Just trying to create the demo environment so that I can show you how this binary authorization work. So within the binary authorization, there are a few major elements. First, the signer, right? Obviously, this is the component to sign the note, right? To create that explicit trust, to sign it with the private key, and then the note or the attestation will be stored in the metadata store. And then when you or the CI or the CD tools trying to push or deploy the container into Kubernetes, the attester will be triggered by the admission hook and trying to validate this note with the policy, with the defined policy. If the policy allow, then the Kubernetes cluster can run the container. Obviously, if not, then it will be rejected and you see error message, right? So this is one of the very important tools that you should use in your runtime environment as a gatekeeper to make sure the binary, the artifact, right, the applications running in the actual production environment, it's gone through all the security testing, gone through unit testing, gone through integration testing, right? This is the kind of the last gatekeeper. If you don't do that, no matter how many tests you run, you won't be able to make sure the binary running in your production environment is actually gone through all the tests or not. So, and you should also use different kind of policy. For example, in QA environment, you have a QA policy. And obviously for production, you have a set of policy for production environment. And obviously for production environment, the policy will be tighter. Yeah, there will be more constraint in the policy for production environment. So in this example, as you can see, in order to deploy a version of your application to the dev environment, you can define a policy that require attestation called security. And then in the QA environment, you can add some more policy. For example, you need to go through the development environment plus the security. And then production will be security plus development plus QA, right? So this will make sure the binary will push to production, gone through all the security tests, gone through the test in the development environment, gone through the test in the QA environment, right? To create a safeguard for all the workload going to be run in production environment. Policy management. I'll show you some example policy in the demo, but I think the point here is to treat the policy as code so that it is auditable, so that it can be tracked in a source control repository, and it can also be tested before use, right? And then you should keep your policy in a repository. Can be sometimes you can keep it in the same repository as the application, but sometimes I think in some bigger organization they might want to keep it separate in another policy, in another repository that managed by, for example, security team, something like that. But yeah, either one is possible. But the point here is that to keep policy as code and in a repository, so that it can be integrated with your CICD tools. Break glass. As I mentioned, if we go back to here, in order to push the application to production environment, if we have this policy saying required X, Y, Z attestation, as you can imagine, the time required will be quite long, because it need to go through dev, test, QA, staging, etc. Some of the clients I met, they have 7 different environments before going to production. So it is also essential to have a break glass emergency process. For example, if something happened in the production environment, like if you find some ransomware in the production environment, you should fix it ASAP, right? So if you want to fix it ASAP, exactly why you need break glass process. You need to break the glass and then have a special procedure to allow you to push the update to the production environment as quick as possible. Because if you're not quick enough, the consequence could be very bad. You could end up leak sensitive personal data, and then you'd be fined heavily. So you need these kind of process to make sure you have a different set of procedures to make sure you able to push update to production environment more quicker. Yeah, but also at the same time, obviously you need to use the break glass procedure very, very carefully. Otherwise, you do not want to see this happen, and then someone push some malicious code using this special emergency process. All right. See if my demo environment is up. Yeah, it seems up. Let me. Let me open. I just want to show you the binary authorization, the last part, because all the rest, they are quite easy to understand. And I'm sure some of you might already using those kind of scanner, etc. But the binary authorization, I think, is something more unique. I haven't seen lots of enterprise, especially using this mechanism to for gatekeeping. So I have an environment. Let me show you some. I think I have multiple cluster here already proficient. Yes. As you can see, I have two cluster, one QA and one production cluster. Obviously, QA will be used for testing, and after testing, I can run it in production cluster. And in order to have this binary authorization, as I said earlier, there will be two major steps, right? The first one will be after you've done certain scanning, testing, right? You create attestation or you create signature. So you need something, right? You need a pair of keys. So in this environment, demo environment, I have some keys here in the key management system called binary authorization. And in the key inventory, I have two signer, one for development, one for QA. So obviously, if you come back to here, you can see for applications running in the dev environment and gone through the test, will create those, will need a signer in the development environment, right? So this is the key for that signer here. And the other one, QA signer, will be the key running in the QA environment. So I have two keys. And then let me show you the binary authorization. It is so I've created two attester, right? Development attester and QA attester. So this is actually the one to use the key I showed you to sign the task, right? So, I mean, you need to save your key somewhere. In this demo, I save it in the KMS in Google Cloud, and then you create a tester, right, to bind the attester to that key. Obviously, the development attester is binded to this development signer key, right? And then the other one, QA attester, is using the QA signer key, the private key, right? And then that's the basic setup. What I need to do now is to create a policy. This is an example policy. For example, there it says default admission rule, always deny, right? Always deny. This is what you should do. You deny everything, and then you can create a policy here to allow the workload running in that cluster only if it is, it contains the attestation created by this attester. So this QA cluster, right, for applications to be able to run in QA cluster, you need the signature from this development attester. And then for applications to be able to run in production cluster, you need two attester, the development and QA. So let me run this. Bear with me, just need a few more seconds. So I have this binary bin of policy, and then just need to run this command to create that policy. It's something. Okay, maybe I just go through this with you. So after you create those policy, as I showed here, after created this policy, right, you should be able to see if you're trying to push a application to Kubernetes without the attestation, what you will see will be something like this. You'll see something like admission webhook, violates policy, which deline the request of running some image, right, delined by binary authorization cluster. Right, this is because of this delined by attester, development attester, saying no attestation find that were valid and signed by a key trusted by the attester. So what it done is to the attester in the binary authorization, the gatekeeper will check the metadata storage, which is the embedded in the artifact repository in GCP. And then find that this image contain no attestation, so that the gatekeeper denied the request. What you need to do if you want to run it in the QA environment is you need to create attestation. How to create it? After you run some task, you trigger this script. You run this script. For example, you run this script after a security test in your CICD pipeline, right? If the test return execute 0, then you run this script to sign it. This script is easy to understand. So container, binary authorization, attestation, sign and create, and then provide all the parameters like which project, which artifact, right? This is important, right? You want to create attestation for a specific image with a specific digest, and then specify the tester, tester project, which key to use to sign, and obviously those key location, the key projects, right? You can only run the workload in Kubernetes by creating attestation if you have that policy created. And then again, For another one, will be the same. If you run it in production environment, you sign and create attestation. But this time you use a QA tester, right? This will be run after your QA testing, right? After your integration test, after your test using Selenium, for example. If all the tests been run successfully, you trigger this, right, to sign and create attestation. And then the workload will be allowed in the production Kubernetes cluster. Right. I think this is the basic concept of how to make sure your artifact be promoted correctly from QA environment to production environment. Make sure that the artifact been running in production has gone through all the required testing, collected all the required attestation. Okay, I think I'm overrun. See if anyone got any question.
Hello.
Hmm.
So far, there doesn't seem to be any questions, but I do have questions of my own. So I guess in the
Yeah.
meantime, if there's any questions by any viewers, do just post it on the comment section. We'll go to it as soon as we see it. But yeah, in the meantime, I got some questions that went through my head as we go through the session just now. So one question that kind of pondered me from like quite a while is, okay, so in the G Cloud CLI command, right? There's this there is this functionality where, let's say, for Cloud Run or Cloud Functions, you can actually deploy it straight from the developer machine straight into a cloud environment. And I mean, in my personal opinion, I feel like this is bad practice. But what is your opinion on this? Like, is it a good practice, or is it something to be encouraged? And like, what are some of the steps or some of the reasons why this should be discouraged, and what ways should be done, or what is the proper way to deploy stuff to such environments?
Yeah, very good question. First of all, I think Cloud Run is Cloud Run does support binary authorization already. If not already, it will be soon. So that's mean what I mentioned just now, right? Create gatekeeper, allow that to verify the attestation be created or not, right? It will be supported, available in Cloud Run. And then rather you should use this binary authorization or not, it will be depends on the business, let's say. If the business, but I think most of the time, well, how can I put it? If the organization is a really small startup, right? It may not You may not have so many security testing, or may not have so many different environments. Then you can manage the security easier, right? Because let's say the team size is small, right? Only a few developer. The developer themselves can manage it quite easy. But if the team size getting bigger, and then the organization is big, like a bank, they have separate organization. I mean, separate team to taking care the security, right? That like in the bank, they have CISO, and then they have a bunch of security engineer to create the standard policy, etc. Right? Obviously, then at least the production environment should use the binary authorization, right, to safeguard to as a gatekeeper to make sure the binaries verified it, etc. Yeah. So I won't. I say it really depends. Um, Security checking is definitely required for all the company, I'd say. But rather or not using this kind of gatekeeper will be, yeah, depends on the size. So,
Okay. Okay, I guess that's also like a good point to kind of note about like the size of the company and like whether they can manage the risk. If the company feels that they can still manage the risk, like even when they deploy it straight from dev machines, I guess that's I guess that's one way to look at it. But yeah, I guess like I guess it like me being from a more enterprisey kind of background, I see that as more like a big red flag. But yeah, I guess like your point of view also kind of makes sense where maybe they don't have enough manpower to actually look into this thing like properly and like trace the
exactly.
whole process, because it takes effort and manpower to actually
Yeah,
maintain them,
exactly.
right? Yeah.
As you may know, in Google Cloud, we do have different kind of customer. We have quite a lot of enterprise customer. If this is a question from an enterprise customer, I definitely will tell them to use binary authorization. But at the same time, we also have quite lots of startup using Google Cloud. So the team size may be, yeah, quite small. They just start. So yeah, that will be my recommendation. If they think they okay to manage the security by themselves with a small team, I think that's fine.
All right. Okay. So there's one comment so far, and the comment is just like saying that so far no questions. But okay.
Okay.
Um. Let's. I guess in the meantime, if there's any other guys like still pondering any questions, just comment. But okay, let's move on to another question that I have also. Uh. So. Um. So the question is regarding these strollers. You mentioned this like quite earlier in part in the slide. So I did play around once or twice with some of those strollers images, and like they are, how do I say it? They are particularly a bit difficult to kind of use. I mean, like
Mm,
essentially, let's say if you want to debug with it, essentially, maybe I'm not sure. Maybe it's the distroller's image I'm using, but there's no shell within it to tinker around and to find out what's wrong with it. Like essentially, if you deploy it on a cluster or you deploy it on like a Docker container in your own computer, there's no shell. So basically, you are kind of tinkering things blind. Like basically,
mm,
you can add images and everything, but like you can't debug it. Let's say if there's a situation where maybe your app fails to start up, but you're not sure whether is it like lack of files or is it lack of resources. Like yeah, it's difficult to debug. So is there any like tips on how to work with distroless images from your end?
um, yeah, good question. I think it may be so. In the development life cycle, right? I think at the very beginning, sometime the developer may not be very familiar with the runtime. Yeah, the container runtime. It may make more sense to allow them to create something with a non-distress image, so that they can make sure their applications running can run in a container environment at least. But then after um, you know after some days, after they got familiar, I think it will be make more sense to have a more strict environment. And then also, um, once those developer, once they familiar with the environment, they know what they need, and then they don't need those two, for example, shell, right? To just to make sure a certain file appear in a certain directory. They one after a certain level of development, then I don't think it will be needed. Then yeah, as mentioned, it will be. I get your points. It will be easier at the beginning. Yeah, I agree. But then before you push it to a staging environment and production environment, it will be better to adopt the distro-less, right? And also because it's a security best practice, and also it will it will help you ensure that you leave no backdoor in the container image.
All right. That does make sense. Yeah, it does make sense. Okay.
Okay.
So basically, like basically, if they are not familiar with distro-less, work with something like more mainstream, which have all the utility tools that they can use. And then once they are more familiar with it, and as you progress through the environments, switch to a more stricter,
Yeah.
more tight container, right?
Right.
Yeah. Okay. I guess just one more last question. So, this is also another question that I was kind of pondering as well. So regarding some of the processes, like, are there like a growing number of organizations that are already implementing the processes that you mentioned about the attestation and etc. Like, are they using Google Cloud for it, or are they like utilizing some open source tooling for it? And it's like, who owns this process? Like, if the CI process like proceeds, and then somehow the attestation just didn't run properly, and then the rules are not applied properly, like, is there like a particular team? Did they form a particular team just to manage this process, or is it like, does it fall under security team, or does it fall under the DevOps team? Like who owns this process? Like, what do you
Um,
see so far the trends in
yeah.
among customers?
So I'd say more and more enterprise trying to adopt it. They, as I mentioned, lots of enterprise they didn't. Right, they focus a lot in DevOps. Right, they focus a lot in speed up the development life cycle, but then they also rely on a very heavy security checking at the later stage. Now, I think with in the last 2 years, right, the DevSecOps concept being very popular, and then also security all the time, right? They are the top concern of an enterprise. So yeah, from this year, I've seen more and more enterprise clients trying to adopt this what I called shift left on security or DevSecOps, right? And so yeah, they've been using quite a lot of tools. Some are open source, some on Google Cloud, as mentioned. Some of the tools are open source, created and open source by Google, like the Graphia and Critters. So it's already embedded with some of our tools, like binary authorization, like the artifact repository, right? It's already embedded, so it's easier for them to adopt. But if they run on some other cloud environment, they I've seen some create using, like, for example, create a metadata storage using Graphia. They they create it by themselves. Not really very difficult. Just you need to manage one more thing. And the last question is about the working model, right? I would say it is a shared responsibility. So what I mean is they have usually, as you said, they have DevOps team. They also have security team. Security team usually define the standard policy, etc. Right? and then telling the developer you should implement or you should make sure your binary aligned with my standard. That's the past. But now, the core concept of DevOps and DevSecOps is not only about tools, right? It's about the culture. They need developer, operator need to cooperate, and now DevSecOps, developer, operator, and security engineer, they need to cooperate. So I mean, if a client, if a company, right, they use a lot of tools like CICD, right, or binary authorization, but they do not work closely, it's actually violate the concept of DevOps or DevSecOps, and it will be very hard for them to, to be successful, to go. By successful, I mean allow them to go fast and secure at the same time. It will be hard, yeah, because it's not something a or multiple tools can help easily, right? In the enterprise, there are thousands of people working together. Yeah, so cultural, the working model is, yeah, a bit of is rather new to enterprise, I would say, but I've seen more and more enterprise clients, they are shifting forward to more, cooperative, work closely. So back to your question, DevOps team or security team is there's no clear cut, right? They need to work together closely to make sure the whole process is, yeah, streamlined and secure at the same time.
All right. Thanks for your answers, Derek. So there's no other questions that come in. Do you want to mention this slide? Like you switch to this
Yeah.
slide.
So folks, welcome. Yeah, thanks for your time today joining this session. So we love feedback. So please use this form to, yeah, send us feedback. You think this is useful, or if you want to hear more, some other topics, right? I think you can use this form to tell us.
All right. Okay. So as Derek mentioned, like if you want to give any feedback regarding this, yeah, just scan the QR code or just slowly type the form URL at the bottom there, and then you can reach out to uh some Google. I guess like it goes directly to you, Derek. The
Uh,
form.
it's not going to directly to me, but I will get the feedback.
Yeah, you get
I
the
think
feedback.
it will
All
be
right.
forwarded to some of my colleagues.
Yeah. Okay. So yeah, or if the questions like you are pondering about some stuff and like me, you can just like leave comments in the video as
Yeah,
well.
sure.
Like if someone will eventually look at that and like will give their 2 cents about
Yeah,
the
good.
video question. Yes.
Love it.
Yeah. Okay, so with that, thanks, Derek. Thanks for your time, for sharing this topic. I'm pretty sure this topic is actually like quite vital to most people, although most people don't generally think too much about this. Generally,
Mm,
security is like usually one of the lower priorities, although it should be higher up on
exactly.
the thought processes. Yeah, with so many security events happening, like even this year, it can no longer become with just two hands. You need your hands and feet to count the number of security events that happened this year. So
Totally.
yeah. So once again, thanks, Derek. I guess we'll see you next time. I think that you will have maybe another session, maybe sometime this year again, or maybe next year. But yeah, okay. Thanks.
Yeah,
I'll
thanks, Harry.
yeah, I'll remove you from the stream.
Yep. Bye bye.
All right. Um. So, with that, um, there's a session sharing by Derek. So he shared about secure software supply chain. And with that, it comes to the end of this webinar. But before we end, just a few quick announcements. So as usual, we are on a constant lookout for speakers. So right now we have a few, but then it's always nice to add more to the pipeline. If you wish to speak about any topic, Android, Kotlin, TensorFlow, you can just reach out via that URL, and it sends you to a Google form, and you can enter your details, and then we'll direct you to the appropriate developer group. So if you are talking about not really cloud stuff, but maybe some Google related technology like Android or TensorFlow, or Kotlin, there is another uh, group, Google developer group. They focus on those set of technologies, and they will set the session for you, and you can have your sharing there. So yeah, if you wish for opportunity to speak to a community, just go through that URL down there. And before we end this session, just want to have the usual end of every YouTube video, all our socials. So if you wish to keep up with what GDG Cloud Singapore is doing, what we are sharing, what sessions is happening, and what knowledge tidbits that we have available, you can just join any of these social URLs. So Facebook, Slack, not so much. It's not as active, but mostly on Facebook. If you want to find out like what webinar sessions is happening, you can go onto Meetup or the a new channel, GDG Sites. So you can go there and see, and like watch for watch for what sessions is coming up. So yeah, with that, that's the end of this webinar. So I guess see you next time.